So topic 112 is all about determinants of square matrices. Let's just do a quick recap of some notation here. Recall that we use capital letters to denote actual matrix. So we would say, notation, if a capital A is some matrix, 1, 2, 3, 4, say, then we denote its determinant by, and there are a couple of ways you can write down determinants. You can abbreviate DET and put the matrix letter in it, or you can surround the matrix letters with vertical bars, or you can surround the actual matrix itself, like swap out the brackets with vertical bars. Either way denotes a matrix. Now, denotes a determinant. Now, what a determinant is just a unique number that's associated with every square matrix, 1 by 1, 2 by 2, 3 by 3. And to find it by hand requires a particular pattern. So we're only going to talk about two sizes in this topic, 2 by 2s and 3 by 3s. So let's go ahead and talk about them. So to find the determinant of a 2 by 2 matrix, say for example, suppose I ask you to find 1, -3, 2, -1. So notice I use vertical lines, not square brackets, so this is a determinant, not a matrix. The idea is that you're going to multiply the numbers along the diagonal. Which diagonal? Well, first you're going to multiply along the main diagonal. So this guy here would equal 1 times -1. And then you're always going to subtract the other diagonal, 2 times -3. And then the rest is just doing math. 1 times -1 is -1, minus 2 times -3 is -6, and then 1 minus -6 is 5. Easy peasy. Let's just do one more example just so you guys get the idea. Find the determinant of -5, 0, 3, 2. So we're going to go ahead and do this crisscross subtract business. So multiply along the main diagonal. So that's -5 times 2. Always subtract the product of the other diagonals, 3 times 0. And then do some math. That's -10 minus 0, which of course is -10. I would say that the determinant is -10. So 2 by 2s, you do this crisscross subtract business. To find the determinant of a 3 by 3, it's a little bit more work. There are lots of different ways to find determinants of a 3 by 3. The fancy, formal, rigorous way is called cofactor expansion. I think we're going to talk about a faster shortcut in this video. So, for example, let's say I ask you to find the determinant of, say, 3, -1, -5, 5, 1, 2, and 3, -1, and 1. So the shortcut is to take the first two columns of your matrix and copy them on the outside. So I'm going to take this column, 3, 5, 3, and write them on the outside. Take the middle column, -1, 1, -1, and write them on the outside. By doing this, you sort of expand your matrix so we can still do this crisscross subtract pattern. So let's go ahead and calculate it. The only difference is instead of having one diagonal in each direction, you're going to have 3. So you're still going to do this multiplication business, but you're going to add up all the diagonals in the end. For example, the first diagonal here is 3 times 1 times 1, plus the second diagonal here, -1 times 2 times 3, plus the third diagonal here, -5 times 5 times -1. It's always going to be minus, and you do the other 3 diagonals. So we have the first diagonal here, so that's going to be 3 times 1 times -5, plus this diagonal here. So it's going to be -1 times 2 times 3 plus the last diagonal here. 1 times, oh, I guess I don't need parentheses there. 1 times 5 times -1. So you can see how a 3x3, it just makes the work a little bit bigger, but it's the same premise. It's the same idea. Do the blue diagonals minus the yellow diagonals. And then you just do math. So equals, let's do the first blue here. So 3 times 1 times 1 is 3, plus -1 times 2 times 3 is -6, plus -5 times 5 times -1 is a positive 25. Always minus, and then do the yellow. 3 times 1 times -5 is a -15, plus -1 times 2 times 3 is a -6, plus 1 times 5 times -1 is -5. And then some arithmetic, and we're home free. So for the first blue, if you add them all up, you should get a 22. Minus, for all the yellows, if you add them all up, you should get a negative, let's see, what is that, 26? Yeah. And then 22 minus a 26 is a 48. So your determinant is 48. I suppose we have time to do one more. If not, you can just shut down the video and go ahead and get started on your practice. But if you needed to see this worked out one more time, let's just do another quick example. Say, find the determinant of 1, 0, 4, 2, -1, -4, 1, 3, -2. So step 1 is copy the first two columns on the outside. So 1, 2, 1, 0, -1, 3. And then what you're going to do is go ahead and make your diagonals. So my first blue diagonal here is going to be 1 times -1 times -2. Plus, second diagonal, 0 times -4 times 1, plus the third diagonal, 4 times 2 times 3. That's all the blues, minus the yellows. 1 times -1 times 4, plus second diagonal, 3 times -4 times 1, plus the third diagonal, 2 times 2 times 0. Well, actually, that's a -2. -2 times 2 times 0. But it doesn't really matter because we're multiplying by 0. So then let's go ahead and simplify all the pieces. So for the blue bracket, the first parentheses will be a +2. The second parentheses will be a 0. And the third would give us a 24. I'm just doing the arithmetic really quickly. All I'm doing is just multiplying the numbers. Minus, let's do the yellow. The first yellow parentheses is a -4, plus the second parentheses is a -12, and then the third parentheses is a 0. Finally, we can do math. That's 26 minus a -16, and that gives us a 42. So that's how you find determinants of a 2x2 and a 3x3 matrix.